Geometry Lesson 2.3, we'll be talking about conditional statements. Let's determine whether each statement is true or false. If a polygon has 6 sides, then it is a hexagon. Is this true or false? This statement is true. A 6-sided polygon is a hexagon. If a polygon has 6 sides, then it is a pentagon. This statement is false. A pentagon is a 5-sided figure. Reasoning involves compound statements that use connectives that make one statement rely upon another. These are called conditional statements. A conditional statement is a statement in the form of if P, then Q. We symbolize this as P implies Q. We can also read this as P implies Q, as I just did. P is the hypothesis and Q is the conclusion. So P is the hypothesis and Q is the conclusion. Let's return to that last slide. So if a polygon has 6 sides is the hypothesis, then it is a hexagon is the conclusion. Conditional statements are statements that depend on each other. Conditional statements have a relationship to each other. The following statement is conditional. If a man is unsaved, then he will spend eternity in hell. The hypothesis of the conditional statement is a man is unsaved. And the conclusion of the conditional statement is he will spend eternity in hell. After identifying the hypothesis and conclusion of statements, it will be easier to write them in if-then form. Example 1 from your book asks us to write these 3 statements in if-then form. First statement, there are no clouds in the sky, so it is not raining. If there are no clouds in the sky, then it is not raining. School will be canceled when a blizzard hits. If a blizzard hits, then school will be canceled. Sometimes it will be necessary to invert your hypothesis and conclusion to make the sentence be true. A triangle has 3 sides. If a figure has 3 sides, then it is a triangle. This conditional is true. Let's take a look at a truth table for conditionals. The only way a conditional can be false is if the hypothesis is true and the conclusion is false. This is different from when we were doing truth tables for conjunctions. In conjunctions, both statements had to be true for it to be true. So, in a truth table for conditionals, we have true, 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 false, false, and then our next combination would be false and true, and this would still be a true condition as our answer. Our fourth statement will be false, false, and this would also be true. So the only way a conditional can be false, and here's the situation right here, is if the hypothesis is true and the conclusion is false or does not satisfy the hypothesis. Is the following answer to the conditional true or false? if a hexagon has 5 sides, then a peach is a vegetable. Well, let's look at this independently. A hexagon has 5 sides is a false statement. A peach is a vegetable is a false statement. So, they're both false. So the hypothesis is false, and the conclusion is false. So if the only way a conditional can be false is if the hypothesis is true and the conclusion is false, then the answer would be true. Let me say this again. The only way a conditional can be false is if the hypothesis is true and the conclusion is false. In this situation, both the hypothesis and the conclusion are false. Let's look at the previous slide in the table. False, false, true. Example 2 from your book. Coach Jones promised his players, "If you win the championship game, then I will buy you a steak dinner." Let's determine the truth value of this statement in each case. So the coach bought the team a steak dinner after they won the championship game. This statement is true. The hypothesis was met and the conclusion was satisfied. Okay? So this makes sense. The coach bought the team a steak dinner. They won the championship game. Now let's look at the next statement. The coach did not buy dinner after the team won the championship game. Well, why would he not buy dinner after the team won the championship game? This statement is false. The hypothesis was met, but the conclusion was not satisfied. The team still won the championship game, but the coach didn't buy dinner. So, the hypothesis was true, but the conclusion was false. And so this makes the statement false. This would be the second row in your truth table. The coach bought the team a steak dinner after they lost the championship game. Well, you'd say to yourself, maybe he felt bad, but we don't know why he bought them dinner after the game. So this statement was true. The hypothesis was not met, but there was no obligated conclusion. So he bought the team a steak dinner, which was our original conditional. And that statement is true. So the whole conditional will be true. The coach did not buy dinner after the team lost the championship game. Well, this was the natural outcome of what he originally said. So this statement is true. The hypothesis wasn't met, but there was no obligation in the conclusion. He didn't buy dinner, but the team had lost the championship game, so it's a true statement. So the only statement that was false was the second one on our truth table. That was example B in your book. Remember, a conditional is always true except when the hypothesis is met and the conclusion is not satisfied. Related conditions can be formed from any given conditional. We can have a converse of a conditional. It is obtained by reversing the hypothesis and the conclusion. We did that with one of our previous examples. So the converse of P implies Q would be Q implies P. You can have an inverse of a conditional, and that's obtained by negating the hypothesis. That's when you would say the coach did not buy dinner instead of the coach did buy dinner. And also, by negating the conclusion. So the inverse of P implies Q is not P implies not Q. The third condition is the contrapositive of conditional. It's obtained by negating and reversing the hypothesis and the conclusion. So you would negate P implies Q, and then you would reverse them, and your outcome would be not Q implies not P. Before we go on to example 3, let's do a few problems similar to some of your homework. Homework problem number 2. Write each statement in if-then form. I will go sledding when it snows. If it snows, then I will go sledding. A square is not a triangle. If a figure is a square, then it is not a triangle. The intersection of two lines is exactly 1 point. If two lines intersect, then their intersection is exactly 1 point. So we had two lines, the intersection. So if they intersect, then their intersection is exactly 1 point. You could probably rephrase this a little bit, but it's important that it make enough sense that someone will understand it. Let's look at number 8. State whether each conditional is true or false. If a prism is a cylinder, then it is also a cone. This is one that many people get mixed up. This is false. If a prism is a cylinder, then it is also a cone. A prism is a cylinder. That part of the conditional is true. But a cone is not a cylinder. A cone has one base, and a cylinder has two bases. So this would be false. Example 3. Write the converse, inverse, and contrapositive of the following conditional. If the measure of an angle is 135 degrees, then the angle is obtuse. This is a true statement. This conditional is true. If the measure of an angle is 135 degrees, we can agree with an angle can be 135 degrees. Then the angle is obtuse. This statement relies on the first statement. This conclusion relies on the hypothesis. So, the converse of this. The converse is to reverse the hypothesis and the conclusion. If an angle is obtuse, then the measure of the angle is 135 degrees. The converse of this conditional is false. An angle can be obtuse, that's true. But we don't know what its measure is. An obtuse angle can be anywhere greater than 90 degrees and less than 135 degrees. Let's do the inverse of this original conditional. We negate the hypothesis and the conclusion. If the measure of an angle is not 135 degrees, then the angle is not obtuse. If it's not 135 degrees, it could still be 150 degrees, and then the angle would be obtuse. So this is false. And writing the contrapositive, this means we negate, then reverse the hypothesis and the conclusion. So if an angle is not obtuse, then its measure is not 135 degrees. And this is true. If an angle is not obtuse, that means that it would be a straight angle, which could be 180 degrees. It could be an acute angle, which is less than 90 degrees. In example 3, we find that the original condition and the contrapositive condition are true. The converse and inverse do not always have the same truth value as the original condition. This leads us to our next theorem, the contrapositive rule. A conditional is equivalent to its contrapositive. This is theorem 2.3.1. Let's take a look at one more homework problem. This is problem number 15. The instructions are to write the converse of the conditional. So if two lines do not intersect, then they are parallel. So with the converse, if two lines are parallel, then they do not intersect. Go ahead and do your homework. Be sure to contact me if you have any difficulties. And we'll talk about biconditionals in 2.3b.